Hello everyone. Today we're going to work on exponential growth and decay. So we've been looking at exponential functions and we graphed some, and we also evaluated some yesterday where they gave us the story and the equation. And there were a bunch of different examples of what an exponential function is, and there are a lot of examples in the real world. So today we're going to look at not just evaluating them, but actually being able to write equations before we solve them. So here's an example of something that we did yesterday in some of your homework problems. It says, suppose you earn $2,500 at a summer job and you decide to invest it into an account that earns 3.5% interest compounded daily. Use the function, and then they gave you the function to find the value of money after 20 years. And yesterday what we did is we basically tried to just pick out what does our X stand for so that we could plug it in, and what do we plug in for that? So that's the piece we did yesterday. Today we're going to actually write an equation like this. And so I want you to notice that suppose you earned this $2,500 right here. That's the initial amount we start with. That is always going to be outside your parenthesis. And in this case, this is called compound interest. And so the 3.5% interest that you see here, well, that's not going to be a great color. Let's see. This 3.5% interest, that actually is in the equation right here. There's your interest. Now, 3.5%, remember, 3.5% means 3.5 out of 100, which is equal to 0.035. So that's one thing you're going to do today is change interest, or change interest written as a percent, and write it as a decimal like this. That's what goes into the equation right there. So the compounded daily part is interesting because they don't always just compound interest once a year. Okay, when it's compounded daily right here, that means every day, and there's your 365 days in a year. So if we solve this problem, it says we would put 20 in for time, so we would have 2,500 times 1 plus 0.035 over 365 raised to the 365 times 20. And remember, we talked about yesterday, you need to either put parentheses around the 365 times 20, or you need to just write in that answer that equals 7,300. Because otherwise, if you just type in 365 times 20 at the end, it's going to calculate the whole parenthesis to 365, and then it's going to multiply it by 20. Also, we talked about that you need a parenthesis around these, an extra parenthesis, or you can go ahead and divide 0.035 by 365, and then that gives you a decimal, which in this case, that does not seem right, so 0.035 divided by 365. I think I multiplied on my calculator. Okay, this is giving me 9.59. I'm a little skeptical of that, but okay, we'll leave it. So then you could do 1 plus that number, or you could actually just add it to it like that. But when you calculate this answer on your calculator, and again, practice doing this, it should give you approximately $5,034.21. All right, so those are some pieces I wanted to just point out from yesterday. Make sure you understand. Please email me, message me, or I am going to have a Zoom session, so check out the details in the course update. I will have a Zoom session today, so you can join if you have some questions. All right, so this is for your notes. You might want to pause the video and add this to your notes, okay? Exponential functions, we already talked about it, where x is the exponent. That's what makes it an exponential function. And we've talked about this several times, but we need to define these variables. So make sure you understand that A is the initial start value, and B is the growth Or in some cases, things aren't growing, they're decreasing, as you saw yesterday. That's the growth or decay factor. And that B right there, that B is also equal to our 1 plus our rate, okay? So oftentimes you're going to see it, as you did in that last example, as 1 plus a rate of change. In that case, in the example we just did, it was 3.5% interest. That's the rate that you were gaining your interest. So we're going to actually now plug in from the story, we're going to plug in the initial start value, the growth or decay factor in there, and we're going to put the variable in. So this is what exponential growth looks like, because we're going to keep adding that rate of change. So that's why there's this plus in here for growth, okay? And again, your B value is 1 plus that rate. Your X, usually written as T, because X is usually time. So it could be in years, it could be days. So X is usually the time. Okay, so what are words that you should look for, okay, that mean growth right here would be things like increasing, or words like grows, okay? I mean, growth is usually pretty easy to determine, okay, but decay is a little trickier, so we'll add some more words there. Okay, again, notice on the B value right here, this is important, that B value, the R right there, is always written as a decimal. So you take that percent that you got and you divide it by 100. All right, so let's try an example. Again, feel free to pause the video, make sense of it, and then move on. So it says, suppose the population of a country was 250 at the last census. If the population grows at an annual rate of 3%, what will the population be in 10 years? So you can see we have this formula up here. Here's our formula. So now we're going to plug in. Remember, our A is our initial start value. Okay, so our A right here is going to go in right there. So that 250 is going to go right here. So I'm going to have 250. And then I'm going to have my parenthesis, okay? And I'm going to have 1 plus my rate. So what was my rate? Well, my rate was 3%. So here's my rate of 3%. So remember, that goes in right here as a decimal. So 3% is 3 divided by 100, which is 0.03. So you just divide that on your calculator, and whoops. That's for compound interest, so we'll just put it in like that. And then last but not least, our time, okay? We want to know in 10 years, so our T is 10. So that's basically what happens, okay, is we plug all those things in. Yesterday we only had to plug in the time. So then we go ahead, we calculate the answer, okay, and you're going to get an approximate answer. And so you start with 250 people, and after 10 years, if it's growing at 3% each year, you would get 335.98 people. Well, of course, you can't have part of a person, so a lot of times we just round up. But you can leave it as a decimal, because we all understand you can't have 0.98 of a person. You know, you're not cutting off just their hand or something like that. So we just use that in general. Okay, so here is decay. Okay, decay is when things are decreasing. Okay, so when we look at decay, words that mean decay would be like shrinking. So the population might be shrinking or declining or decaying. Okay, but there's some other like words that you might not be as familiar with. Decreasing is pretty common, but there is a word called depreciating. And what that means is usually like a car, when you buy a brand new car, it depreciates or loses value over time. So those are some words, keywords to look for to know that this one is decay. And the only thing that's different is it's subtracting the rate of change because you're not increasing your number, you're decreasing, okay? All the rest of the variables are all the same, okay? But here is your decay formula. Again, remember that B, okay, is really just 1 minus your rate or 1 plus your rate of change. So let's do an example of decay. The population of a city is 136,000 and is declining by 2% each year. Find the population in 6 years. So my key word here is declining, and that's how I know it's decay. Okay, so I know that I'm going to subtract my rate. So let's pick out what is our initial starting value. The population of a city. Okay, this is our starting value. That's our A. So we have our starting value A of 136,000. Okay, we're going to multiply that by 1 minus our rate. And what is our rate? Our rate is 2%. So it's 2% per year. So 2% is 0.02. And how long is it declining? What is our time? Our time is 6 years. So I put a 6 in right here. Now, when I go back, enter all this in my calculator, now I can enter this. There's nothing tricky about it, but I can enter all of that in one step, and that is going to give me that the population after 6 years is about 120,474.56 people. Okay? So remember that B value I said right here, that B, okay, is really just this right here. And if you want to look at some of the ones we did yesterday, they actually already did that. How do you get that B? Well, if I take 1 minus 0.02, that gives me 0.98. So you could also write this equation as 136,000 times 0.98 raised to the 6th power. You may have seen some written like that yesterday. That's just they did that before they calculated. All right, so that's basically it. You practice writing those equations. You have your notes out, okay? Fill in the correct A and R and T, okay? And then tomorrow we're going to get into a little bit more complicated growth and decay formulas like compound interest and half-life, something called half-life. So if you're feeling comfortable and confident, you can stop now and you can go right ahead to the homework, which is posted in Schoology. I'm going to go through one from your homework right now. So if you want to grab your homework, pause the video and walk through one of your homework with me, feel free to do that. Otherwise, have a great day, but I'll do one of these at least. Okay, so it says a new car is worth $25,000 and its value depreciates by 15% per year. Find the car's value after 6 years. Okay, so what is your A value? Your A value is the initial starting amount. So what's the initial value of the car? It's $25,000. Okay, and it's depreciating by 15%. So my R, or rate, is 15%, but I don't put in 15%. I have to put it in as a decimal, 0.15. So that 15% has to be turned into that decimal. And then what is my T, time, in years? How long is it depreciating? I want to know what its value is in 6 years. Okay, so now I take all of those things and plug them in. So y equals, and I'm going to have 1 plus or minus. Is this going to be plus or minus? Well, remember, it's depreciating, so it's subtracting that rate of change. So let's take our initial amount, 25,000. We're going to take 1 minus our rate, which is 0.15. And we're going to see how long, or see what happens after 6 years. So again, we enter all of that into our calculator in one step, and that is approximately $9,428.74. And that is actually for real. Cars depreciate the day you drive them off the lot. So it's kind of stinky, but it happens. All right. Again, you can check out, go to your homework right now. Otherwise, I'm going to go through one more. I'm going to go through number 17 next. So it says an antique car is worth $32,000 and its value grows. So the last one depreciated. It was a new car and the value is going down. This is an old car and its value is going up. So we know this equation is going to be let's clean that up a little bit. This is going to be 1 plus our rate, okay? So what is our A value? What's our initial value? What's our initial starting amount? $32,000, okay? And it's growing at a rate of 7% per year. So my 7% does not go in as 7, it goes in as the decimal of 7%. So take 7 divided by 100, that gives you 0.07. And how long is it, how long do we want to know? After 5 years. So 5 years, put a 5 in there. Okay, so then we take our calculator and we take 32,000 times in parentheses 1 plus 0.07, and then we raise that to the 5th power. And that gives us the value of the car, okay? After 5 years, it's grown in value quite a bit. It is now $44,881.66. All right. Well, good luck. Again, join me for Zoom if you